Have you ever wondered what happens after your system unexpectedly switches to a backup server during an outage, and then the original primary system comes back online? It is not as simple as just flipping a switch back, is it? There is a crucial process involved to safely return to normal operations. Failback is the systematic process of returning operations from a secondary or backup system to the original primary system after a successful failover event. While failover is often an urgent, reactive measure to restore service during an outage, failback is a more deliberate, planned, and controlled procedure designed to ensure data consistency and minimal disruption when moving back to the preferred operating environment. The primary distinction lies in the nature of data synchronization and system state. During a failover, the goal is rapid service restoration, potentially accepting some minimal data loss if the backup system is not perfectly up to date. In contrast, failback requires meticulous synchronization of all changes that occurred on the secondary system back to the primary, often while the primary system remains temporarily offline or in a read-only state. This prevents any data divergence or overwrites that could lead to data corruption or loss. To execute a successful failback, you typically need to prepare the original primary system, ensuring it is fully recovered and stable. Next, a critical step is to establish synchronization from the currently active secondary system to the primary. This might involve transferring incremental data changes, verifying their integrity, and ensuring all services are ready to accept traffic. Finally, a controlled switchover occurs, often during a scheduled maintenance window, to direct users back to the fully updated primary system. This careful process addresses key metrics like recovery point objective, or RPO, and recovery time objective, or RTO. Your RPO defines the maximum acceptable amount of data loss measured in time, and RTO dictates the maximum tolerable duration of downtime. Proper failback planning minimizes both by meticulously ensuring data integrity and allowing for a graceful return to the optimal operational state. Achieving a quiescent state, where all ongoing transactions are completed before the data transfer, is often a critical internal step to guarantee data consistency. Understanding failback as a distinct, deliberate process, rather than just an inverse of failover, is vital for designing truly resilient and highly available systems. It transforms an emergency recovery into a planned return, safeguarding your data and maintaining seamless service delivery over the long term.
If this helps you code smarter, like, subscribe, and stay tuned for more.